Welcome to solverfy.
Alright, so problem 20 is a bit of a long one only because there are 4 parts, but for part A, and I should start with the fact that we're given a 2 by 2 matrix that looks like this. Part A simply wants us to find the inverse, right? And so we're going to use this formula, and the formula states that in the case where if we sort of let our 2 by 2 matrix be represented by A, B, C, and D in this way, then the inverse is going to be D over the determinant, which is AD minus BC. All right, then negative B over the determinant, negative C over the determinant. So all these are going to be over the determinant. So we could have pulled that out and written it in front as a constant. You'll see that sometimes. Okay, but with this handy formula, all you really need to do is start plugging in numbers, right? So we know what A, B, C, and D are. It's going to make this negative 3/5, two fifths, 1/5, and 1/5. All right, so our determinant is going to be 3 minus 2 for negative 5. So we had a negative 5 at the bottom of everything here. And then we were plugging in the numbers on top. So that's how we get that solution. And then we move on to part B. And B is asking us to cube A. And so A was this 2 by 2. So when you're cubing it, you're just going through the process of multiplication 2 times, right? So first we can sort of we can square it. Which will give us 3, 4, 2, and 11, right? Because we take each row and column and multiply their corresponding parts and add it together. Okay, then so that's just squared. So we'll multiply it by a squared by a to get a cubed. Okay, then by the same process where we sort of take each row and each column, going through that process we'll get 1, 18, 9, and 37, right? So to get 1, we took 3 times negative 1, added 4 times 1, that equals 1. To get 18, we took 3 times 2 for 6, added 4 times 3 for 12. Total is 18 for there. To get 9, we took 2 times negative 1, added it to 11 times 1. And then for 37, we had 2 times 2 plus 11 times 3. Okay. So then we skip ahead to step C. Okay, and this time we are cubing our inverse. And so by a similar process, we'll take the inverse that we found here in part A. Okay, so that is negative 3/5, 2/5, 1/5, and 1/5. And just like before, we'll start by squaring it. So we're going to just multiply that by negative 3/5, 2/5, 1/5, and 1/5. Okay, so we take -3/5 times -3/5 and add that to 2/5 times 1/5, which will give us 11/25. Okay, and then we'll take the same row, 3/5 by 2/5, but this time we'll take -3/5 times 2/5, and then 2/5 times 1/5. Add those together and we'll get -4/25. Repeat the process, so 1/5 times -3/5 plus 1/5 times 1/5. That'll give us -2/25. And lastly, I would take the 1/5 times 2/5, add that to 1/5 times 1/5. And this time we get 3/25. Okay, but then since that was just a square, we need to do this again. We'll multiply it by our inverse matrix again. And repeat the exact same process of multiplying them. Okay, so we take 11/25 times -3/5, add that to -4/25 times 1/5. That's going to give us -37/125. Okay, so then we take the same process of 11/25 times 2/5 plus -4/25 times 1/5. That'll give us 18/125. Okay, same process, new row. So we have -2/25 times -3/5 plus 3/25 plus 1/5. That's going to give us 9/125. And then again here, we'll take -2/25 times 2/5 plus 3/25 times 1/5, and that'll give us -1/125. So now the final part is that it wants us to show that the inverse cubed, which is what we did in part C, is the inverse of a cubed. Okay, and so what we are then really showing is that those two multiplied by each other is going to equal the identity. Okay, so we'll take then our inverse cubed, which is this kind of crazy -37/125, 18/125, 9/125, and -1/125. And then we'll multiply that with what we found in part B, the a cubed. So that was just 1, 18, 9, and 37. Okay. So let me go through the process of just multiplying these together. All right, so we'll take a row with one column, right? So here we'll get -37/125 plus 162 1/25, which we get from multiplying the 18 1/25 by 9. Okay, and then we'll repeat the process. So same row, but the next column, so we'll get the negative 37 1/25 times 18 plus the 18 1/25 times 37. That's actually going to give us negative 666 1/25 plus 666 1/25. And then we'll do the same thing for the next row. Go back to the first column. So then we get 9 1/25 minus 9 1/25. Okay, and then the last section is this second row again, but second column, and we get 162 1/25 minus 37 1/25. Okay, and so this is actually equal to, let's see if I can fit it down here, our identity matrix. So that checks out. Okay, and it's not a bad idea to go ahead and go through and also show that then as the identity, a cubed times the inverse cubed is also equal to the identity.